Okay, dear children, I'm teacher Geeta. This is grade 10 physics topic, refraction of light. The last two videos I explained about general wave properties and reflection. Now here it is explaining about refraction of light. You know that what is refraction? Refraction is the bending or changing the direction of light when it travels from one medium to another. Here it is showing the glass block or glass prism. The light is traveling from air to glass and glass to air it is traveling. Here this is an example of refraction. If you put a pencil on the water, the top of this one, you can see that it is bending. But this process is called refraction, the bending of light rays when it passing from one medium to another. Then the law of refraction. Refraction of light is the phenomena of change in the path of light as it travels from one medium to another. It can also be defined as the phenomenon of change in speed of light from one medium to another. That is from air to glass and glass to air. So what are the laws of refraction? The first law indicates the incident ray, the normal, the refracting surface at the point of incidence and the refracted ray all lie in the same plane. We have to see that all lie in the same plane. Incident ray, this is the refracted ray, normal, and here also incident ray and refracted ray, normal, all are placed in the same plane. Second law, for a given pair of media and for a light of a given wavelength, the ratio of sine of the angle of incidence to the sine of angle of refraction is constant. So mu, we have to say that mu is equal to sine I by sine R. The constant mu is called refractive index. This is represent refractive index of the medium. So refractive index is equal to sine I by sine R. I is the angle of incidence and R is the angle of refraction. The sine of angle incidence divided by sine of angle reflection. But these are the two laws of refraction. Next one is, what do you mean by refractive index? The last slide we said that one, mu we represent refractive index. What is the definition? It's defined as the ratio of velocity of light in vacuum to the velocity of light in a substance at the same wavelength. This one we have to say the equation speed of light in air divided by speed of light in the medium. The absolute refractive index of medium is simply called refractive index. But here is showing an example, the refractive index of water 1.33. This means that the ratio of the speed of light in air and the speed of light in water is equal to 1.33. And similarly, the refractive index of glass is 1.52. So, it is defined as the ratio of velocity of light in vacuum to the velocity of light in the substance at the same wavelength. Now, what do you mean by total internal reflection? How this total internal reflection happens? Here it is, see, the total internal reflection is defined as the complete reflection. Total implies that word, from that word we can understand that the complete reflection of light ray at the boundary of two media, when the ray is in the medium with a greater refractive index. For total internal reflection to occur, the following conditions are: the light ray must travel from an optically denser medium towards an optically less denser or rarer medium, from glass to air. Glass is a denser medium, air is a rarer medium or less denser medium. This total internal reflection happens when light must travel from denser medium to rarer medium, and the angle of incidence must be greater than the critical angle. Here show what happens if the angle of incidence is greater than the critical angle. When the angle of incidence, here I, angle of incidence is increased beyond the critical angle, and the light ray will be reflected back to the glass block. No light ray is refracted. Here it is the ray coming towards the glass, and here hit it and it is not refracted, it is completely reflected. This is the reflected ray in the same medium. But this is known as total internal reflection. But no light passes through if the incident angle I is more than the critical angle. That is why the total internal reflection occurs. How the total internal reflection occurs? Always the light must travel from optically denser medium to rarer medium, and the angle of incidence is greater than critical angle. Then we have to say that total internal reflection is happening. Now what do you mean by the critical angle? When the angle of refraction is at 90 degree, the incident angle is called the critical angle. In the picture you can understand the critical angle is the angle of incidence in a optically denser medium for which the angle of refraction is 90 degree. See, here it is, the glass, and this one, look, less denser medium air, and here the normal, the angle of refraction is 90 degree. But this light is incident ray and this is the reflected ray, and here it is no refraction going on, and here it is totally reflected. The total internal reflection occur. So when an angle of refraction is at 90 degree, the incident angle is called critical angle. Here it is C represent in the picture it is showing that C represent the critical angle. Now action of optical fibers. Everybody know that now in everyday life we are using that one, the optical fibers. But fiber optical fiber are long thin strands of very pure glass about the size of human hair. Now our hair size only that much thin, that fiber. They are arranged in bundles called optical cables and are used to transmit signals over a long distance. And it is used in telecommunication. You know that now in the phone we are using, in our phone it is connected through optical fibers. The telecommunicator is using digital signals can be communicated by the cables. It is thinner than conventional cables. And in medicine also we have to use examining inside the body for endoscopy. See, in this picture you can see that one. It is used in medicine also, that optical fibers. Next is, what do you mean by monochromatic fibers? Monochromatic means the single frequency light wave. Okay, single frequency wave is called monochromatic. Most light occurs or emit continuous distribution of wavelength. But for our study it will be easier to consider that light that is made to shine at only one frequency and wavelength. The light, it has only one frequency, that we have to say monochromatic light. Or a best example of monochromatic light is laser light. Okay my children, I think you understand this one. The next video I will explain about the thin lenses and electromagnetic spectrum. And watch the video carefully and do the worksheet also.